Right, good afternoon, everyone, and welcome to our CAWASA Wednesday webinar. This evening, we have our guest presenters are Mr. Ted Bailey and Doug Thompson of Aureus Solutions, Inc., out of Canada. They have done work in the Caribbean. They were last year in St. Lucia, early February or mid-February, and made presentations to WASCO, and thereafter we got into the lockdown. So we are happy to have them again because they had planned to visit with us, but we're doing that virtually this time. So I'm going to go immediately and ask Ted to proceed and introduce his team and just a little background about Aureus, and then they can get into the presentation.
Sure. Why don't I actually jump right into the presentation, because I've embedded that information in there. So now if I just press share screen.
Yep.
Okay.
Good. And do your right shoot.
Okay.
Brilliant.
So is that, everybody can see that?
Yeah.
Great.
Perfect.
Okay, good afternoon, everybody. As Ignatius mentioned, we're giving a presentation slightly modified, but similar to what we gave in St. Lucia in February. And it's about improving performance of treatment plants with a focus on enhancing existing resources. Enhancing skills and resources within existing staff, I should say. So basically, in layman's terms, improving quality, reducing risk, reducing costs by using existing infrastructure, existing people, and through modifications to operations, maintenance, and management practices. So we've been doing this sort of service, if you will, since 2005. We're, as Ignatius mentioned, we're a Canadian-owned firm that we've primarily worked in Canada, US, and a bit in the Caribbean with WASA in 2008, 2009. We have been we were under a big push to work again with the Caribbean. We're doing quite a bit of development at the annual conference, and we've actually met with some of you over the past year and a half, but COVID threw a wrench into those plans. But we are hoping to restart some of that. And basically what we do is we're not a design firm. Although we are an engineering consulting firm, we focus on, again, people first, ground up solutions where it's focused on skills transfer. So we do a lot of procedure development, operations and maintenance procedure development. We do a lot of process consulting, health and safety assessments and hazard analysis, and maintenance and asset management consulting. So what we're going to talk about today is a program that was actually developed, or a tool actually, that it was developed by the US Environmental Protection Agency back in the 70s. And at the time, the United States had invested quite a bit of infrastructure money in the 50s, late 40s, early 50s, and these treatment plants were aging, and the government realized that they needed billions of dollars to upgrade these systems to current standards, to meet compliance requirements, to meet performance requirements, etc. So in an effort to identify cheaper alternatives, they developed this composite correction program out of the Denver Drinking Water Office. And the goal of this program was to identify opportunities to improve efficiency, reduce costs, work with existing infrastructure in order to extend the life of these systems where possible. And it was very effective, but surprisingly, it kind of fell off the map. And I think one of the reasons why is that from a consulting perspective, there's not as much money in this approach as there is in designing new treatment systems or designing new processes. And so that's what we're going to talk about today, is the thought process that goes through identifying what the root causes of the particular issue are. So we're going to go through how one does that and what the typical root causes are, and some success stories about how we addressed some of these in our experience. So I've mentioned a little bit about this. The approach of the Composite Correction Program is to work with operations and maintenance and management staff to identify areas of improvement. And it's really focused on empowering these individuals to ensure improvements are accomplished and sustained. And I'll go through how one does that. In a way, it's a very simple formula. It's often about just listening. Most of these solutions are already available with existing individuals, the operators such as yourselves who have been working at plants for years, but sometimes the communication gets jumbled. Sometimes the messages get lost. Sometimes there's just been a change in focus, or sometimes it's just easier for a third party to re-express some of this information. So what are some of the benefits? This will become more clear as we go through the methodology, but essentially it involves establishing baseline O&M practices. And so we'll get into this in some of the examples, but in some of our experience, and probably yours, there are differences in O&M practices, maybe between operators, between shifts, maybe between generations. And these O&M practices can sometimes result in either several paper cuts, if you will, that impact performance, impact production, impact risk, or they can be actually individually quite significant, but sometimes hidden in amongst the noise of the treatment process and alarms and other issues. But that is one of the benefits. By agreeing upon standardization of O&M practices, we've seen tremendous results, which we're going to share today. Some of the other benefits: historical knowledge and lessons learned are captured at the activity and equipment level. So this is something we're seeing a lot, and we're being called in a lot for these days, is experienced operators nearing retirement. Whether it's one person working at a facility or a very senior operator with junior operators. And sometimes maybe this senior person is unwilling to share information for fear of whatever. So what we do is try to tease that out and help pass on that knowledge to the younger generation or the new generation, whatever it might be. And with this process, often, because it's a sharing, collaborative process, staff are empowered and bought in because they're part of the problem solving and solution. And in addition, managers, it opens up a black box often for managers because they're involved as well. And I'm saying managers both at sort of the process level, but above that as well, especially those who control the purse strings, the money. By sharing these challenges in a collaborative way, and even as a third party sometimes saying something that has maybe been said numerous times before, there may be more opportunity for someone to hear that and change can occur, which is what we often see. So as sort of an example of the importance of each one of the elements, operations, maintenance, design, and management. Doug is going to give a local example of how these factors combine into a single disastrous event in Canada.
I'll just get you to flip one more.
Yep.
There we go. Thanks, Ted. Hello, everyone. I'm Doug Thompson. I'm the manager of water and wastewater operations for Aureus Solutions. I've been with them, I guess, since 2015. Prior to that, managed municipal water and wastewater facilities. So as Ted said earlier, quite often some of these performance indicators can lead to small paper cuts. But this particular example, and as you see from the slide there, I call it the perfect storm. As we know with many events other than Mother Nature, and Ignatius and Ted and I were talking about the tornado season down in the Caribbean. Other than Mother Nature, though, most emergencies and catastrophes are not the result of any single event. Usually, what occurs is that a number of smaller events combine, and the resulting outcome leads to a complete failure. And this is a classic example in Ontario here of those small events culminating in probably one of the worst municipal tragedies that we've seen in Canada when it comes to municipal drinking water. And as a result, the inquiry that resulted from this tragedy led to changes over the course of the next 15 years. And we now have in place what we call a multi-barrier approach, which maybe in a nutshell is to put in place mechanisms that if one particular component fails, it doesn't lead to the catastrophic tragedy that we saw in Walkerton. So a little background on Walkerton, and as we go through it, and as we go through the rest of the presentation, I want you to think about the performance limiting factors that are going to be discussed here when it comes to the composite correction program, and how some of those factors that are identified are similar to what you hear as a result of what happened in Walkerton. So Walkerton's a small town population of 5,000. And in the spring of 2000, Southern Ontario, which is where it's located, experienced what's not uncommon, some traditional spring rainfall. In this particular case, some heavy rainfall over a course of a few days. And weeks later, the town of Walkerton was never again the same. And the reasons for that is that as a result of contamination of the drinking water supply, 7 people out of 5,000 died, and 2,500 people were infected. And as a result of the E. coli infection, have health concerns for the remainder of their life, particularly kidney issues and others related to the infection from the municipal drinking water supply. As I said, that tragedy changed the water industry in North America significantly. And the inquiry that was held was led by Chief Justice Dennis O'Connor, and the report itself came out in two parts. The first part being looking at the circumstances that caused the tragedy, which is primarily where we're going to focus today when we talk about the composite correction program and addressing risk and also minimizing or averting emergencies and emergency repairs. The second part of the report actually identified 123 individual recommendations that formed the multi-barrier approach that I spoke of in order to enhance and ensure and minimize the potential for any tragedy like this occurring in the future. So again, Ted spoke to the key performance indicators when it comes to the composite correction program being design, administration of the system, and operation and maintenance component. So I'm going to just speak to some of the key findings from Chief O'Connor's report and categorize them into those three areas. So if we although I can't see individuals participating today, I'm sure there's going to be many of you shaking your head with some of these items that are mentioned as findings from the report. So first of all, from a design perspective, the report identified, following a review, that the E. coli contamination was entered into the Walkerton potable water system through an existing well. Walkerton had 3 primary wells that fed their system, and this particular well, number 5, was in service at the time of the spring rainfall. Also, it was identified, going back one step, if we look at that from that standpoint, having 3 wells, and we look at the performance limiting factors, in one way that's a good thing because there was redundancy in the system. They did have alternate sources that they could rotate through as required, and that's one of the keys for ensuring your source water protection. Further, it was identified that the primary source of this E. coli, and it was a specific strain, E. coli 0157 H7, which is quite a deadly strain. The primary source of that contaminant was from manure that was spread on an agricultural farm adjacent to the well. And obviously, subsequently, because of the rainfall, the well was impacted with the manure. It was further said in the report that the farmer, the agricultural neighbor who spread the manure followed all acceptable procedures, and therefore they couldn't be held accountable for what ultimately occurred. The third factor from a design perspective was that the town had been told on a number of occasions that well number 5 in particular, because of its location and because of some of the surrounding activities, and because of the geology that it was completed in, was suspect and therefore should be considered to be removed from service. That had never occurred, but it had been recommended previously. So a number of design factors that contributed to the problem. From an administration standpoint, the Ministry of Environment in Ontario here would be considered your regulator in the Caribbean. So the regulator, the inspection programs had detected in the past some problems with the treatment in Walkerton. However, there had never been an appropriate follow-up or corrective actions taken. And also, the government of the time had reduced funding to the particular regulator, and as such, they didn't have the resources or manpower to really follow up as should have been required. So an administrative breakdown, administrative breakdown at the regulator level. At the owner level, which in this case was a Public Utilities Commission, a board of directors that were governed by the town of Walkerton. Of course, they weren't aware of some of the issues that were occurring. However, some of the board of directors had been on previous councils and had been made aware through the regulator that there were significant issues, not only with the operations and maintenance of the system, but with the funding of the system as well. And again, they chose not to act on those recommendations, and ultimately that was a contributing factor as well. And as I mentioned, the the provincial government was in a cost-cutting and cost savings type of attitude at the time, and as a result, they had reduced funding significantly, which again impacted the oversight of the facilities, as well as the support available to facilities seeking help. So a number of breakdowns, both at the provincial level there and at the ownership level of the facility. And third, and a very large contributing factor of the catastrophic failure was the operation and maintenance of the sites. The operators really didn't have the expertise or training when it came to drinking water treatment. They typically were local people who had been hired by the municipality. In some cases, there was some nepotism. The manager, his name was Stan Cable, and he had a number of family members working at the utility in an operational capacity, and none of them really had the knowledge appropriate for operating and understanding the complexities, the chemistry, and some of the potential hazards when it came to drinking water treatment. As well, the biggest problem associated with the rainfall and the manure that was spread on an adjacent farm was not that the E. coli entered the well, but rather, and again related to the operational knowledge, but rather that that particular well, well number 5, the chlorinator, which was a common disinfection used at the 3 sites, the chlorinator for that well had failed. And it had failed 2 weeks prior to the particular event. And there was no repair parts on site or really no urgency to repair the chlorinator, as they've never had issues previously. So what occurred was, without chlorination, therefore the bacteria was able to enter the distribution system. Now, also at the wells, there was no continuous chlorine monitoring, and therefore there was no indication that in fact there was no chlorine being applied. And again, from the standpoint of operations, for years the operators had engaged in a host of improper activities, least of being manipulating results, falsifying records, making up chlorine residual readings, and as such, it was commonplace that record keeping was lax and in some cases falsified. The operators ultimately indicated that they knew that this was a problem, but it had become the norm. So, and then further to that failure and those breakdowns, after they did receive results from the local health unit, of problems with the drinking water supply after the hospital had been inundated with people with gastrointestinal problems. First call was to the municipal water supply, and they had received results from the lab indicating that there was contamination, and the general manager chose to, for more than a week, not share that information and continue to indicate that there was no problems. So all of those factors contributed to half of the population being impacted significantly by this event, and ultimately 7 people losing their lives. So again, that particular event changed our water industry, and there could be a complete webinar on the multi-barrier approach that was adopted as a result of this incident. But again, certainly a lesson learned the hard way, and that perfect storm, without a doubt, could have been controlled and managed a lot more appropriately. So with that, I will turn it back over to Ted to speak about the Composite Correction Program more in detail. And again, think about some of those events that I just mentioned and how they relate to the approach to addressing and improving water treatment.
Great, thanks, Doug. Sorry, everybody, to jump in. A few of you were asking about whether we were switching slides. Maybe that is a lesson learned for next time. This was a single slide for the story, but we will be switching slides here moving forward to describe some of the other examples. So Doug gave an overview of essentially what can go wrong in an extreme case, but the variety of things that can contribute in an overall disaster. And I guess what we're going to share with some of these examples is that we actually see some of these things all the time, but individually they are overlooked or deemed, non-critical, but it's difficult to assess what the potential impacts are if these issues combine into a single event. And it's unlikely that something like Walkerton is necessarily going to occur, but what we have seen is just things as in increased alarm response, more frequent alarms, more frequent upsets, more frequent performance issues that can become part of day-to-day life, and the root cause is almost lost over time. And we'll sort of talk about some of that. So Doug mentioned performance limiting factors. So we're going to be talking about performance limiting factors on operations and maintenance first, then admin, and then a little bit on design. Not so much on design because we don't necessarily have control over design, and those are often easy to identify, right? Something doesn't work or isn't in place or isn't the way we need it. But operations and maintenance and admin are something that we're exposed to every day, and these can maybe apparent at the current moment or in the past, but sometimes get watered down over time or even lost. So some of the issues, and Doug, jump in at any time, some of the general issues that we see on operations and maintenance, testing, in particular process control testing, in order to identify in the early stages potential issues, representative sampling. So I think we even have an example in here about representative sampling. And what I mean by this is taking samples that are representative of what we want to understand and figure out. There's process control, This could be anything from understanding to application to troubleshooting. Operational resources, Doug mentioned insufficient training in Walkerton. This is a common issue. CAWASA is obviously a great organization for dealing with this. What we see when we mention training, it's often specific to your individual facility or facilities, right? It's one thing to understand the basics, which are, of course, your baseline knowledge, which you need. But then there's the next step, which is understanding your unique equipment, your unique system, your unique challenges, and under a variety of conditions. So that's what sort of mean by training. Technical guidance goes hand in hand with that. Operational guidelines and procedures. Most plants have general guidelines and procedures. However, from our experience, they're developed during the commissioning stages by the engineering consultant, and they are written for really, they're typically written process-based rather than activity-based. So what I mean by that is, how do we operate this clarifier? How do we operate this pump? But it's more generally speaking. Whereas when an operator is performing their functions, they're performing their daily checks, they're performing their weekly checks, they're performing individual maintenance activities. And often procedures and guidelines are not written to the do level. What do I do? And what do I do if the normal conditions are not in place, i.e. we're in abnormal conditions? What are the abnormal conditions and how do I respond to them? We often see maintenance programs either incomplete or without checks and balances in place. So very common issue is a piece of equipment that isn't working anymore, but the operators are able to find workarounds, and typically they're waiting for management to provide the funding to address these issues with this equipment. That message gets lost over time, and eventually the workarounds become normal conditions. Then that ends up a spiral effect on all sorts of other impacts on the plant. And that leads into maintenance resources, having the available spare parts, having the materials, having the financial support.
And maybe I'll just jump in a bit there, if you could back up.
Yep.
Again, maybe just to elaborate from the operational perspective, Ted's last comment is bang on. First of all, an operator's role is to ensure that the system, be it a water or wastewater facility, continues to operate 24/7. And for a number of different reasons, an operator will find a way to make the system work if there is equipment breakdown or problems. And that's a common thing, and that's kudos to the operational group. The problem is, as Ted had suggested, one, that becomes the norm, and secondly, then that one particular modification can lead to issues with others. So from the process control testing, obviously we can't control or understand what's happening with the system without proper testing, and therefore one of the areas that is easily improved on from the standpoint of operations is to make sure you're testing at the right frequency, the right locations, to give you an understanding of how your system is working. And again, the representative samples, as Ted said, the sample has to be representative of what you're trying to achieve. The process control, again, as Ted said, doing the testing and getting the results are one thing, but understanding and interpreting those results are key as well. And a lot of that comes with mentoring amongst yourselves, or from the standpoint of some of your training, understanding as you learn, and experience, obviously. So again, critical. And to that end, also, Ted mentioned that typically you'll get a lot of training from the individual suppliers of components, but from the standpoint of the overall treatment process, it's how those individual processes work together and the impacts of changes in one process stream and how they ultimately impact the overall outcome. So again, operations is definitely a learning curve, and each individual facility is absolutely unique. So it's like math. You need to know the basics and then apply the basics and expand your knowledge from that point.
So I'm sure many of you looking at this see potential challenges that you're facing at your facility. These are not unique. We see them wherever we go, bits and pieces of them. But I guess to back up, how do we go through the process of identifying these? And so again, the composite correction program outlines a evaluation step. It's called a performance evaluation. And it involves going through each one of the administrative, O&M, design questions. Got over several hundred questions that one would go through and evaluate their system. And a lot of it is, again, what you're going to see today, common knowledge. A lot of it is probably already understood, but what becomes apparent as you go through it is sort of the number begins to grow, especially as we dig into certain activities. Now, we've started to shift our approach to identifying these performance issues to a different methodology. We originally were using the composite correction program, but we've modified it and actually started focusing on operations and maintenance procedures. So what we do is we go through each individual activity that one would perform at your facility. So this is right from what's the daily tour of duty, what is the weekly, what's the monthly, what's the annual, and within those, of course, there are sub activities, right? Greasing a pump, changing a filter, sampling, and even within that sampling, what type of sampling, clarifier sampling, finished water sampling, etc. And we start going through each one of those and describing the basic steps, describing the normal conditions, abnormal conditions, how one responds to abnormal. Then we would go to each individual operator and confirm those steps without showing them the details of what we've collected. We would confirm those steps to see if there's any deviations between those activities. And often 99% of the activity will be done the same from one operator to the next. But within that, 5 to 10%, 1%, whatever it is, deviation, that's where we then identify and work with the entire group to figure out how exactly we want to do this. What is the correct way? What are the best practices say? What do the operators say? What do the maintenance staff say? What does management want, right? And we combine those and come up with a solution. And often the decisions are very small. what we need to do, and typically quite easy. But as I'll show you in some examples here. So this was a plant. These are effluent results from a wastewater treatment plant. And the numbers represent individual sampling results that were above target conditions. So doesn't mean they're out of compliance. They were just above the compliance limit for one individual sample. And you can see 2010, 30, seems like a lot, but individually they're always in compliance. Same thing, 36, well, very close to 30, so seemed good. 19, hey, we even did better than this year. But then all of a sudden disaster struck in 2013 and the plant went into complete upset. There, as I said, there had been no historical compliance violations. There were several theories, including the influent became toxic, somebody dumped something in. That's a common one that we hear all the time. That management had never fixed certain equipment, so of course that finally caused an upset, et cetera, et cetera, et cetera. But what we discovered as we started going through is that performance data was there, but it was suspect. There wasn't consistency. There was only 2 operators there at the time, but they were relatively new. There was a previous operator about 5 years earlier, 2010, and the data seemed to vary. And despite them doing the same sampling plan, right? Same sampling points, same frequency, et cetera. There had been some workarounds that had been implemented, again, because funding had been lax. But again, they had managed it fine to date. There were some, again, these maintenance and design issues. They had been raised by the operators over several years, but again, because management had become accustomed to hearing them, they didn't think of them as big issues, right? And in addition, management really wasn't spending a lot of time at the plant actually seeing some of these things firsthand. So we started going through some of these issues. We started fixing the obvious things, the workarounds. We started collecting better data. We listened to the operators to find out what they thought the issues were. We went through these procedures. And on the procedure side, what we noticed, very interesting, both operators worked different shifts. So sort of Monday to Friday, and then the next operator would come for the next five-day shifts. And one operator was always getting higher MLSS values than the other. And what we discovered was that one operator would stir the sample and then pour it immediately into the filter for their MLSS sample. The other one would stir, then turn on the tap to start the suction in the filter and then pour, allowing a little bit of settling, about 3 seconds, we sort of estimated. And within that settling, there was typically a 300 to 500 milligram per liter difference in the suspended solids. And again, because management wasn't involved in really overseeing this, the 2 operators were on equal levels, so they couldn't really challenge each other, or they did discuss it sometimes, but it was a bit of an internal conflict, if you will. And so there wasn't the ownership, oversight, and support to address this one little issue. And what happened is the wasting then would go up and down like this. And that combined with the equipment issues, some minor other issues, resulted in a complete plant upset that they had never seen before. And so we were able to go through this, work it out with everybody, and the result was very positive because the operators were involved in the solution. They didn't have to agree upon this using the MLSS sampling strategy. They didn't have to agree upon that. We all worked together to figure out a solution, and each operator got to participate. The effluent dramatically improved. The owners and managers became more involved at the plant because they saw what can happen. They saw the impacts of their funding, lack of funding, and you can see the results moving forward have been tremendous.
And maybe I'll just add just a brief comment there. To Ted's point, each of those modifications were small in amongst themselves.
Yep.
And it was just the combination of those individual small changes that led to that pretty dramatic improvement in effluent quality that you saw.
Yep. And this example is the same thing. We were asked to come into this plant. The plant was actually in compliance again, off and on, but they were doing okay. They had been changing operators quite a bit, so there was no consistency. There was limited experience within the existing staff because they were sort of getting fairly junior people. No one paid much attention to the plant because, from a managerial standpoint, because they didn't want to know. And so historical bad practices had started to slip in, workarounds had started to slip in, and all of that knowledge was gone, right? You could maybe tease it out of the logbook, but the logbook practices were a little, and when I say suspect, in some cases, they were keeping a logbook. They were doing sampling, all the previous operators, but without that oversight and support, the logbook became less and less detailed. So then instead of saying, hey, I ramped back the pump by 10% because of this, and I'm going to watch it for 30 days and et cetera, maybe there was no notation at all or just changed pump settings, right? So then when we were asked to come in and evaluate what was happening, we didn't know why changes were made, what changes were made, et cetera. So what we did in this case is we had to do a complete plant reset. We set it back to factory set points, essentially. And we started slowly fixing little things that had gone wrong. For example, we discovered the flow meter, which had just been calibrated, had actually been calibrated incorrectly. And they were reporting a significant percentage more flow than was actually coming in, which was, of course, affecting our recycling, our dosing strategies, et cetera. So getting things like that fixed. The inline instrumentation wasn't working, but of course the operators were taking their own samples with handheld, so nobody thought it was a big deal. But again, when you start looking at the data and realizing, well, maybe the handheld data wasn't accurate and there were some holes in it and we don't know what happened at night and et cetera, then the inline instrumentation all of a sudden becomes very important, and letting that go was a big problem. So we made sure that was fixed back up. We started working with the local operator to troubleshoot, to enhance his understanding of the system, working side by side to troubleshoot some of these issues. And now the plant runs like a top, and everybody is involved and happy, and we can see now that this is going to be a long-term solution because the operator is empowered, the managers know how to support, and it's no longer sort of a ugly stepchild. So I think I'm going to skip these. We've talked about these in sort of some of the examples. One thing we didn't mention is one thing we see often and is a good indicator that there may be some challenges is alarms and overtime hours. So overtime hours dealing with alarm conditions. And again, these can creep up on systems where, hey, it's 5 alarms and then it's 7 alarms, and in 5 years down the road, no one even remembers 5 alarms. Now it's 15 is always the standard. And time and time again, when we actually dig into why are we getting these alarms, how can we fix them, and looking at these three areas and identifying root causes, all of a sudden dramatic changes in terms of that. And that just makes it easier as an operator too. You're not constantly on edge every night. Am I going to get called in? So next thing is administration. So we've talked about some of these examples already. If for administration, this is really management, ownership, kind of combined into one. So policies, health and safety is a big one. Are those in place? Do the operators feel safe and empowered to do their work? Do they have the necessary tools and PPE, et cetera? And tied in with that, are the administrators familiar with the plant needs? Are they coming down? Are they visiting? Are they seeing these issues firsthand, which is tremendously powerful? You see chemical leaking on the ground, it's much easier to say we need to fix this than hearing it over and over in a meeting. Long range planning, again, this is a huge one. Plant staff coverage. This is a constant battle, right? Trying to do is achieve the results with as few people as possible. I mean, sometimes we have to deal with that, but obviously we try to avoid it. Work environment. I'm going to give an example of how work environment can deteriorate quite a bit due to some of the challenges with administration, and it doesn't need to be a bad boss or bad personalities. It can be just lack of support and focus. And of course, financial, right? So this is a water plant that we worked at quite a few years ago now that had a dramatic turn of events. They were, struggling with turbidity. You can see on the left in the gray area. They had numerous studies done, hundreds of thousands of dollars to try to figure out what to do. The general consensus was that they needed a membrane treatment facility, which was going to be $12 million at the time. Significant investment. And we were asked to come in as a last-ditch effort in order to see if we could do anything. There was a lot of infighting amongst the operators. There was no clear leadership. There was even, got to the point where there were drinking issues and et cetera. Operators had different strategies. There was no accountability, et cetera. So what we just started doing is, again, working through the procedures with each operator individually and bringing in the management team to collectively decide how we wanted to try to run the plant, do our best. 99% of the activities were the same amongst operators. There were a few deviations, and those deviations often were very easy to sort out because it wasn't two individuals trying to sort something out. It was a collective team, and the manager was present and supported and offered solutions if one couldn't be identified. And really, then we just started having weekly meetings to see if we were following these procedures, where we weren't, what we needed to adjust. And you can see almost immediately the turbidity improved with no changes to the design. And so it's easy to say, well, couldn't we have just done that by cracking the whip or getting people to do their job? But these little paper cuts occurred over years, 20 plus years in this case. And so it's not so easy. The paper cuts themselves have gone, and the major issues such as the infighting and things have taken over and blinded all the other issues. So when we sort of went back and focused on the smaller performance challenges and procedural challenges and managerial admin challenges, it it allowed us to forget about some of that history and just start fresh and work over. And you can see, and I actually have a quote from the operator in this case. The optimization team helped us remove our tunnel vision from our treatment approach. Optimization opened our eyes to new ideas, approaches, and technologies that's helped us develop as individuals and as a team. So here's one last example for admin. In this case, a simple UV system on a wastewater treatment plant. You can see this is one of the operators performing maintenance, and you may see some health and safety issues right away. The UV system was fine, everything was good, but the operators, unbeknownst to most people, didn't like cleaning or replacing the bulbs. And you can maybe see why. In this picture is actually pretty clean, but it started to get kind of dirty down there. The operator needs to be on the ground. It's a very awkward sort of space, and they just didn't feel like doing it. But they also didn't feel like telling anybody, because I guess they sort of felt like they could do it. They just didn't feel like it was great for them to do. And I think it was mentioned, but I don't know what the response might have been. I'm assuming suck it up and do it. And so over time, the solution was, well, let's just slowly not do it. You know, moving from monthly to a month and a half to 2 months to a year. And of course, at one point, there was a bit of a suspended solids breakthrough in the plant, and which resulted in high E. coli because it kind of blinded the UV system. And the downstream water body that received it is somewhat of a swimming river, and so it raised a lot of concerns. Nothing happened in the end. It was diluted and okay, but certainly caused a lot of fear. And the management may have heard this, but they never actually came down and looked at how the maintenance was performed. And when they saw it, they immediately changed their tune and said, we can't be doing it this way. And we worked out how it was going to be done, whether it's going to be 2 people or whether they needed a crane to pull these things out. Even though they're lightweight, it just is awkward. And a solution was identified immediately. But again, it was easier for us as a third party to come in and bring it up than the operators saying the same old thing and getting denied and eventually just dropping it, because we all get tired of telling the same story and not being listened to. So again, covered some of these. Biggest issue is, I think management sometimes gets fearful because even though they're experienced, as you pull out and move into management, the treatment systems are evolving in the activities we do, so that they become kind of a black box if you don't visit them frequently. And so one of the advantages of trying to write procedures, if you do this at your own facility, and documenting step by step how things are done, how they should be done, historical knowledge, pictures are great, video is even better, then it eliminates this black box, and you can easily show them, whether in a video or a procedure, what the challenge is, and it puts it into a small framework where it allows them to make a simple decision. Ideally, they're visiting the plant regularly, but sometimes that isn't always possible. Communication, again, in all different forms. And a lot of times these lead to lack of trust, which then leads to further problems. So finally, design is one of the last performance limiting factors. I'm not going to go through this. You all know what can happen with design, many different issues. The big thing we see is, the biggest problem we see is during the commissioning period, where an engineering consulting firm and contractors are commissioning the equipment. They maybe have a time frame at which this information is passed over, but there are a lot of things happening during that time period. The operators are new, they're learning. The consulting firm and the contractors want to get out of there as fast as possible. In fact, in a way, they're incentivized to, because then they can kind of ignore problems from afar. And they often don't go through the necessary steps. And this is a perfect example. Doug's familiar with this plant. This is a plant that we've been working on for a few years. The design concept was to provide a completely automated system that would be operated remotely by an operator about 10 hours away, approximately. And this operator would then come in once a month and check up on things, but he'd be able to basically complete all the necessary tasks outside of maintenance from his desktop or his main office. And luckily we were brought in at the commissioning stages and started to go through the procedures and how everything would be done. And what we discovered was that there were a few missing elements to the design that were going to completely unravel the operational strategy that the client had in mind, including no alarm dial-out. So here you've got this brand new plant, multi-million-dollar plant that you want to operate remotely, and there's no alarm dial-out.
Or no ability to monitor remotely.
Or no ability. So those seem obvious. Those were obvious, and they were caught early. But there were other more sophisticated issues that easily could have been overseen and not noticed for months or years, and then by then you're really in trouble, right? Because the contractor and the consultants are gone. You have no leverage. And even as you go on in the 1-year warranty period or the warranty period, your leverage slowly goes away too. And sort of the buy-in by your ownership group also deteriorates because they don't necessarily want to fight some of those battles late on in the process. So it's very important, again, going to this composite correction program or the procedural-based strategy is what we try to do is work with the consultant and the contractors to document exactly, and we even videotape them. Show us how to operate this. Show us how to maintain it step by step by step. And then we document that and we try it ourselves and we see if there's any holes and we compare it from operator to operator. And this is a great way of ensuring that you're getting what you're paying for and you don't have extras down the future or you're forced into workarounds.
And to add to that, as Ted said, the engineering design consultant, one of the areas we're finding is also beneficial is even earlier in the process and at that design stage of the process, because again, engineering consultants are looking at, putting the process treatment together, but not necessarily the long-term operation and how the operator is going to manage. And your most typical example of that is, a valve that will need to be exercised daily or weekly is in a crawl space or is up a ladder rather than at ground level being able to operate easily and safely. That's not their primary focus, issues like that. So again, with some of our clients, they're recognizing the benefit of us having review the design early on and highlighting those particular operational issues. And ultimately, it leads to greater operator buy-in because they acknowledge that they've played a part and the process that they're going to have to manage going forward has been looked at from a long-term operational perspective. So it's very, very common that you see those crazy examples of something being designed that works, but is not manageable going forward.
Yep, yep. These are just other examples where, again, we were brought in as a last resort because the ownership had gone through what, was experiencing problems at their treatment systems. They had brought in engineering consultants who said that the only solution is new design, right? We need to replace the plant, we need to replace the process, etc. And it's frustrating because there are opportunities to identify potential root causes and address those factors without spending all the money. And I'm not opposed to spending money. It's just sometimes going to a new treatment process it's not the best thing, both for the community because of taxes, but also because for operators, it's a huge change going to a new, and you're familiar with this process, you know how to make it work, but maybe you just need the support on the admin, on the maintenance side, whatever it might be, or even some new ideas on the operational side. But often there is abilities to improve without tremendous avoidance.
And to add to that, again, regardless of where we are, everyone has limited financial resources. So a large capital expenditure may be necessary, but if it can be avoided, then that money can be spent and redirected on priorities that we've discussed earlier in the presentation, be it training, be it upgrading individual components or equipment, etc., hiring on more staff. But the reality is that funds are limited, and therefore we should make the best use of them. And new infrastructure is not always the best use.
No, and that Doug put it perfectly. Invest in the people is a good solution often. So, as I mentioned, the sort of subtle changes of digging in and looking at activities step by step. Fewer alarms, fewer overtime hours, less stress for individuals. It becomes a better place to work because we're in control, right? And we know we're in control, and we feel that way, and we're supported. And then it's amazing, the shift moves from emergency response or this fight or flight type work environment to a proactive environment because more time becomes available. We've addressed these lingering historical challenges, and now we can get into that preventative maintenance, which we never had time for. And now maybe management is willing to invest because they know things are working, things are progressing at the plant. So anyway, that's just a quick snapshot. I would have loved to dig into some of the actual analysis that the composite correction does, but you can easily look that up online. And it's so system specific, I didn't think it would be a great topic to cover, but you can find it online. The manual is online for free. And also you're welcome to shoot me an email if you'd like to see a template of what we've done for a procedure. If you'd like to try to recreate that yourself at your facilities, I think it would be well worth the investment.
Right, Ted and Doug, we had some very extensive presentation, and I trust that the participants found it to be useful. I will invite them to shoot any questions if they have any, or any comments they wish to at this time.
Quick question.
Go ahead.
At the foresign of any abnormality at the treatment plants, what will be your advice in terms of the reporting from the operator standpoint?
Doug, you want to?
Actually, I didn't catch the first part of the question.
Yeah.
What specific reporting?
Yeah, any sign of abnormality in the operations at the plant, what time frame would you suggest the operator use to report that abnormality?
Yeah. Well, certainly early intervention in most issues is beneficial. When it comes to critical abnormalities, so non-compliance related issues that might have a health or safety impact either to the consumer or to staff or the infrastructure, the actual facility. Obviously, those are high priority and need to be addressed immediately. Of course, working through the solutions sometimes take some time, but they should be reported immediately. Again, what you're referring to is really due diligence. So informing supervisors, management, the owner, or the regulator of an abnormality. Others can be documented. For instance, problematic things that fail sporadically. Certainly, again, documenting the issue, being able to track and follow frequency. Is the problem increasing, decreasing, staying the same? Again, those can be dealt with at an operational level. But number one, from a management perspective, former manager of a water treatment facility, I want to be informed as quickly as possible so that I can react appropriately as well. So it's in everyone's benefit to share that through communication.
And I would add that regardless of it's maybe a challenging question to answer because of the severity. It can be all over the place, but logbook, almost regardless of the issue, putting it in the logbook is a must. And what you include in that, that's a whole, we actually talked about that in St. Lucia, that we could do a whole training module on logbook writing, because it's surprisingly, I don't want to say complicated, but some thought needs to often go into what you're recording and to what detail. But at the simplistic answer is definitely put it in the logbook in addition to alerting the appropriate authorities, whoever those might be.
Any other questions? Do we have any other questions, please?
One question, good day.
Yeah, go ahead, Ezekiel.
What difficulties do you expect to encounter if there's a treatment plant which is not in operation 24/7 or that's hardly in operation?
What sort of issues do we Is that what you're asking? So for infrequently run system, what kind of issues do we see?
The expected, yes.
Well, I guess I'll answer, Doug, and then maybe you can add. I don't know about issues. Of course, what issues might come from consistency. Right, start and stop operation may be okay in certain circumstances, but not ideal in others. I would want to make sure the design is adequate to accommodate start and stop operation, but also, actually, we were just looking at some desalination facilities that started and stopped. I don't think there was any necessary challenges with that. What we recommended to the owner at the time was that they develop start and stop procedures, and including monitoring and measurement and health and safety, because we didn't get involved in this project. This was a walkthrough, and then we submitted a proposal, but there were some, in speaking to the operators, there were some health and safety challenges that needed to be embedded in the individual activities for the start and stop procedures. So that's another key thing that we didn't talk about is, again, the value of these procedures, whether documented or video, is that you can encompass all the things that one would do. Sampling, SCADA work, physical work, and then of course health and safety. Reporting, for example, if any reporting is needed, communication. So that actually might address the previous question, right? If something goes wrong, what are the things that can go wrong that we want to hear communicated? Now, this would be a manager making that decision, but again, you can document it within a procedure, and now all of a sudden, okay, I'm an operator, I've hit this point, I see that the reading that I'm seeing is not okay. The procedure says report this immediately and stop future steps, or whatever it might say, right? But that's one thing. Doug, I don't know if there's anything to add for start and stop.
No, I was gonna say that there's pros and cons to each. I mean, typically, typically if we're looking at wastewater treatment and operations, it's a lot easier to control a continuous treatment process, both water and wastewater. Most systems are designed for a continuous operation. When you have the 24/7 operation, in a lot of cases, those are staffed. One of the challenges there is, again, the workaround component versus, stopping and starting. Equipment probably works better if you have continuous operation rather than starting and stopping, in particular motors and other components. But again, one of the challenges in successfully starting and stopping systems are that it's done in a consistent fashion. So it may not be the same person starting up that shut down, and so that shutdown process needs to be understood by the person starting it. So, but again, there's pros and cons to each. I wouldn't say that. I would suggest there's advantages to batch systems in some circumstances, but.
Right. Any other questions? I don't see anything in the chat.
Yes, just
Yes.
one quick question.
Go ahead.
The training that you provide, how long is it normally?
Well, so we typically don't provide training in that we work closely with staff to, I guess, work together. So yes, there are benefits of passing on best practices, but it's a collaborative effort. So we do provide training courses, but it's not a primary component of our service. So the typical strategy, depending on where we're starting in the process, if it's an existing treatment plant and we're being asked to come in to identify opportunities for improvement, we would do a free walkthrough basically and look at what we see, and then we would provide basically a conversation for holes that we saw. These would just be surface holes, right? Workarounds. The logbook looked a bit vague. Some of the performance data may indicate improvements, whatever, but usually we're already being brought in for a reason. And then we would recommend a strategy which is typically either an evaluation or starting right at the procedures, because then you're getting value right away instead of another study. You're getting something immediate from it, and that process really involves a lot of training. Again, not training in the general sense, but collaboration with each individual operator and collectively, as well as maintenance and management. So I would say a normal plant takes 2 to 4 days of on-site. And then what we do is we go back and we dictate what we heard. We put it on paper, and it's just draft. This is just what we heard. We don't make any consulting changes or anything, but we do put in questions and comments. And then we come back for another 2 to 4 days, and we work through it with the group and individuals to try to come to a consensus. So total, it's maybe 4 to 8 days on site. Again, depending on the complexity. If it's a well system, maybe it's just even an afternoon. But depending on the complexity, and then the number of procedures that you want to do. And then, of course, the services can go on from there, right? Once we identify particular things, then we can work with individuals. But typically, you'll end up with a video on how something should be done. So you don't necessarily need training, right? This is how we calibrate our pH probe. And we only take a video when we've agreed upon what the procedure looks like. We get an experienced person to do it. We make sure all the steps are correct. And now any young person, new operator, etc., can access this video. We typically put it on a private YouTube channel so that they can get it right on their phone. So when they're at the plant, boom, press play, and now I know how to calibrate my pH probe, not a generic pH probe or not somebody else's, right? And I know I'm hearing from a senior person that I know exactly how to do this. And that also really empowers the people, of course, who are giving the video. They feel great about this. They're sharing their knowledge. Anyway, long story short, I would say 2 to 8 days on site, and then the procedures themselves take anywhere between a month to 2 months to write up.
And a couple other examples to add. And so it's not necessarily technically a training session, but there's training involved, and the outcome actually provides ongoing training and support to others. A good example is chemical feed equipment. So going through how the chemical feed pumps work through PLC control, how they work through manual operation, how to check calibration of the individual pumps. All of that is worked through with the operators and ultimately put on paper and on video. And therefore, it is a historical document for use going forward. Same with jar testing. Virtually every example, there is, maybe not technical, but there is a training component associated with it.
Yeah. It's just not formal training. But Doug's exactly right. And what we often discover, especially on equipment that has been worked around, for example, is that a lot of operators may have never experienced working with that piece of equipment. But if we can get it working again, if it's needed, and we get it working again, then all of a sudden the operators that have worked with it can share that knowledge. And it may be a troubleshooting exercise, and we would get involved, and maybe we even bring the supplier in if needed. But again, that's all part of this training, if you will, but it's not your conventional desktop or in-plant training. It's very specific to what the individuals need to know and what they want to know to achieve the goals of the plant.
Right. Thank you very much, Ted and Doug. I think you've given us about 90 minutes of your time, and that was really fabulous. I got some good comments in the chat room, and I think so far the attendance has been pretty good, and people seem to have picked up quite some good bit of educational information here. So we'd like to thank you again, Ted and Doug, for being our guest presenters and giving us some new, fresh perspectives. And we would like to say thanks to all the participants. You have a question, Ezekiel? No. Okay. So we'd like to thank all the participants who have joined us this afternoon.
Absolutely.
And would like you to keep joining us on CAWASA, what you have dubbed now weekly Wednesday water webinars. And we run that every week, and the participation has been very good. So thank you again, all of you, and we now going to sign off. And feel free to visit our website, CAWASA.org, and our Facebook page. And we also are on Workspace. We have invited most of you who have participated, so you'll find, and we will send the recording to everyone. Thank you very much. And this is where we're going to say goodbye. Have a good evening.
Great.
Appreciate it.
All right. Okay.
Thank you.